Hello everyone, welcome to another episode of What the Code. In this video, what we will do is I will state it. So recently we've uploaded a video on the editorial for educational code forces round 119. So in that contest, there was the problem E. I was very close to solving it, but due to my ignorance on a little bit of things, I made slight errors. So for that I was not, and due to that I was not able to solve the problem that time. But now that I went over it and looked at things with a new perspective, I found the thing which I was ignoring and reached the solution. So in this video I will tell you about it. You can pause the video and read the question, and if you would like to try it, you can work along with me. And so Okay, so if all of you have read the question, let's move to the explanation. Basically should be clear to you that this question utilizes the map data structure. For that, what we will do is that we will store the key values as the value of the array which we have to store, and their indices in a collection, and we will map them with the value which will be stored at them. So the thing that is important is we have to insert we should be the collection should have some properties. The properties are these: that if we have to merge two collections, we should be able to do it in O of one time. Let's say, because if you use vector or set, merging them will be a very hectic process. It will be either n or n log n. These type of processes, these type of complexities you will have, which will give you time limit exceeded on various tests. And insertion is a vector, in a vector is of a 1, and insertion is a set is n log n. So these are also things which we have to avoid where we have complexity of n or n log n in any part. So both vector and set are not working for our case. So what is the thing that we can use? Yes, if you guessed it correctly, what we can use here is a linked list. In a linked list, we can append anything to at the tail of the linked list, given we have the pointer to the tail in O of one time, and we can merge two lists in O of one time, given we have the pointer to both their heads and tails simultaneously. So this question utilizes two data structures both simultaneously. Those are map and linked list. And as for map, we are using hash map, because an ordered map, which is the std map, uses our red black tree, which gives the time complexity of log n. Again, we have to avoid that. We will using unordered map, because an unordered map you have a time complexity of insertion and deletion O of 1 and traversal O of n, which is same for everything. So yes, we will be using an unordered map which will be where the key thing is the value in the array, and it will be mapped with the indices, the linked list of indexes at which it is occurring. So in the query 1 comma 1x, we will insert the size of array into that uh, collection. Let's say if it is 0, we will insert 0, because ARR 0 should be that thing. And if it is 1 2xy, we will merge the collection of x into y and remove the collection of x from the system. So now let's look at the code, how we will do it. Here is the code. So as I said earlier, these are the structures I am using: linked list node, the classic linked list node, which you can find it more about it in the link I will provide for the Geeks for Geeks article in the description. It will have values integer, it has the standard notation, and here we have the linked list. It has two properties, head and tail, and various methods which are useful, like the insert function, which we will use to append at the end, and merge function with the argument of linked list, which we will use to append another list at its end. So these are the methods. This is a constructor, default constructor. This, you don't have to worry too much about it. You can analyze it carefully when I will provide the link to the code. And this is the head. This is basically sentinel, and I will also provide an article to the use of sentinels in linked list. And this is the pointer to the tail, the last element in the linked list, which I said earlier will be useful for insertion and merging two lists. So here we are in the solve function where we are doing most of the part. Integer q, this is the value index map, unordered map of integer and linked list. It's C in Q, the number of queries, S the size of array, it is initialized as 0, while Q minus minus. TXY, T is the query type, and as we said earlier, 1, 2, and XY. This will read the input, insert, and this part, if T is 1, it will read X, and if and insert SZ in the value index linked list, in value index of X linked list, and increase size by 1, basically the size of array. So now, and if there are queries of type 2, we are, and X is not equal to Y, this is an important part. If X is not equal to Y, if X is equal to Y, what should we don't have to do anything, they are already, the thing is already in place. So we have to make sure that X is not equal to Y. And also another thing, that X is in the array, in the map, that X is present. If X is not present, we don't need to do anything to. So these are the things we will do for the if condition. If X is not equal to Y and X is present in the map, we will merge the X to the we will merge X, the list of X into the list of Y, and erase the list of X. So at the end we have done everything. We will make a vector, empty vector of not an empty vector, we will make a vector of size fz, which will be the size of array, because each time we get a query of one, fz increases by 1. So at the end it will basically be the size of number of elements in the array. fz comma 0 by default doesn't matter here too much. And we will look for all the values in the value index collection and get and the linked list has all the indices, so we will resulting vector and index temporary value. This is the standard method of traversing a linked list. You can find this will also be given in the linked list article, which I will provide in the description. And this, while traversing, I am accessing the index and assigning result index the value which is should be there, and moving further, and at the end I will output the resultant vector. And this the thing here, I am printing a vector directly. This is the thing is operator overloading. You can look at the code. I will say this at line 3, it is at line 370, the operator overloading for containers. So this is the thing we are doing for printing the whole container, the vector of integers directly, without anything, any for loop written here. The for loop is written above in the code, the operator overload. So the vector will be printed, and that's the answer. Let's run it. So let's see what it produces. 32232, and answer is 32232. Let's run another input. 4 1 to 1, correct answer. You can match it. Nothing. Last one is this is the last sample, 1337. So our samples are passed. Let's see if it works in the actual submission. So we have pasted our code and submitting it. Yeah. Okay, so as you can see here, the answer is accepted. It is the correct answer, because the important part was here to use a data structure here for the collection of indices. That was the important bit of this question. That was the key part. If we would have used earlier, I was using sets, and it was going time limit exceeded. That was a reasonable output for the content from the judge, because yes, those are slow processes. So here linked list we have optimized it to the very best. So this is it for this video. Keep learning, keep coding, and if there is any doubt, you can mention it in the comments, or you can mail to us. We will provide the email in the description. And keep learning, keep coding. That's it for this video. Bye bye.